Good morning. Welcome to this month's version of the webinar series on applied analytics success stories. My name is Rajesh and I'm the organizer for this series. These webinars are an initiative of the Informs practice session. And on this particular occasion, we are co-hosting it with the Informs Women in ORMS Forum. And Dr. Olga Perdikaki is the president of that forum. Before we get on to the speaker and today's topic, let me give a very brief update or an overview of the Inform section on practice. I hope you guys can see my screen here. So the objective of the practice session is to advance the practice of analytics, operations research, and the management sciences. And to support that mission, this section conducts a number of activities. So on the top, you have the three annual competitions, which are shown partially in blue font. And I guess most of you or many of you would be familiar with some of those competitions. We also have some monthly events. So we have the Applied Analytics Success Stories. The next one is going to be in December 17th. We have a relatively new series called Sustaining Outstanding Analytics Organizations. And the focus here is on the organization itself, the way the analytics organization is set up, the kind of people they have, the skills, the projects. The next one will take place on November 18th. And I believe Facebook will be presented there. And thirdly, we have the monthly virtual networking happy hour, which is held on a Friday, last Friday of each month. Because of the annual meeting, it's going to be held on October 26th, this particular month at a special time of 8:45. Again, if you're interested in participating in some of these competitions or learning about these or want to participate in some of these monthly webinars, go to the webpage for the practice section, learn a little bit more about that, and definitely remember to register for these webinars. And before we go to Robin, let me just hand it over to Olga. Olga is going to talk a little bit about the Women in ORMS Forum. Olga?
Thank you so much, Rajesh. First of all, I would like to thank you for giving me the opportunity to, and WORMS the opportunity to work on this initiative together. So as Rajesh mentioned, I'm the current president of the Women in Operations Research and the Management Sciences Forum. Would you mind, Rajesh?
Oh, sorry.
Showing, yes.
I'm sorry.
Okay, great. And for those of you who may not be familiar with the forum, it was established back in 1995, and the whole idea was conceived over a brown bag lunch. So the purpose of this forum is to promote interest in the issues facing women and the relationship to the profession of operations research and the management sciences. And the forum organizes a number of events around the two main Informs conferences, the annual meeting in the fall, as well as the Business Analytics Conference in the spring. So in a typical Informs annual meeting, we will have the WORMS-sponsored sessions that will be typically a presentation session and a panel discussion. We will have the WORMS luncheon that will give the opportunity to WORMS members to socialize in a relaxed environment. And during the WORMS luncheons, we have a ceremony of the different types of awards that WORMS is presenting. So these are the list of the different types of awards that WORMS is presenting during the luncheon. The awards for the advancement of women in operations research and management sciences. For those of you who are not aware of this particular award, it actually recognizes individuals who have contributed significantly to the advancement of women in the field of operations research and management sciences. And depending on the nominations, we typically offer one award to an individual from industry and then one award to an individual from academia. Then we have the Doctoral Colloquium Award that supports a PhD student to attend the Doctoral Colloquium at the annual meeting, and the Family Care Award that partially covers expenses related to care and travel for family members whose main caregivers are attending the annual meeting. We have a business meeting where we discuss the status of our forum, followed typically by a networking reception. Our networking reception has become so popular over the past few years that I remember back in 2019, we had a very long line of people waiting to enter the venue. And then we have a mentorship program called Coffee with a Mentor that gives the opportunity to our WORMS members to connect with a mentor so that they can get information, advice, and guidance related to their career, both in industry as well as in academia. We also have a subset of similar type of events happening at the Business Analytics Conference. Since the pandemic had started, we have also started a few webinars, and you can see some of our webinars in our WORMS webpage. You can listen to the recordings there as well. And we have had a few digital socials as well, just to get a sense of how our members are doing in the pandemic and get some feedback on the different initiatives that the forum is planning. Can we move to the next page?
Sure.
Thank you. So now I wanted to give you a very, very brief overview of our WORMS events that you're going to be seeing at our annual meeting. So under our WORMS sponsor session, there will be a panel discussion with minority women in operations, research, and management sciences, and that will be on Monday, October 25th at 11 a.m. Later in the day, we will have a career coach discussing about how to deal with imposter syndrome, perfectionism, as well as the tendency that we have to compare ourselves against others. And that will be on the same day at 2:45 p.m. And all those times that are listed are Pacific times. Our business meeting will be on Monday, October 25th at 6:15 p.m. Since we're not going to be having the luncheon this year due to the pandemic, we're going to be hosting our award ceremony during the business meeting, and it will be in a hybrid format. Right after the business meeting, we will have our networking reception starting at 8 p.m. It will be in a very nice venue called the Fifth Rooftop Restaurant and Bar. I heard that you can have a nice view of the Disney park, and if you have the opportunity to attend the conference in person, feel free to stop by. You may get an opportunity as well to watch the fireworks from there. So if you would like to have a more diverse community and more equitable community in terms of gender representation, please consider becoming a WORMS member if you're not already one. I would really appreciate to have more male representation, as men can be great supporters and advocates for women. We are very active in different social media. We have a Twitter account, we have a LinkedIn page, a LinkedIn group, and we also connect with our members through the Informs Connect. So that's all that I wanted to share about our forum. And thank you again, Rajesh, so much for this opportunity.
Hey, thank you, Olga.
I didn't take too much time from
not at
Robin's
all.
presentation.
Not at all. That was a wonderful introduction to that particular forum.
Mm-hmm.
So let's see. Oops. All right. So on to the today's presentation. So just give me 1 second. I hope you guys can see it. Okay. All right. So the topic for today's presentation is using AI to co-develop new product formulations and the future of flavor innovation. And we are very pleased to have Dr. Robin Lougee for this webinar. Robin is a very accomplished technical innovator with a track record of pioneering cross-industry, multidisciplinary research collaborations. During her 26-year career as an industrial mathematical scientist at IBM Research, Robin led technical teams in engagements with IBM and its clients, co-authoring over 20 patent filings. Her project portfolio spans industry sectors including energy, manufacturing, supply chain, logistics, public safety, and finance. Most recently, she led a multi-year research collaboration with McCormick and Company to establish a computational creativity system for AI-enabled product development. This work was featured in the media, including the front page of a special section in the Wall Street Journal. Robin is known for her service to the Informs community, in particular for spearheading new initiatives that benefit industry and academia. She was the founding manager and lead evangelist for CoinOR, the open source initiative for operations research software. She spearheaded the Informs Professional Colloquium, now ECPN, and she was the founding chair of the Syngenta Crop Challenge in Analytics. Robin's contributions have been recognized with the Informs Impact Prize and the Kimball Medal. She currently serves on the National Academy of Sciences Board on Agriculture and Natural Resources and advisory councils at the University of Florida and Cornell University. Robin earned her PhD in mathematical sciences from the Clemson University. Quick note here, we do have we'll have a Q&A section or session after the presentation, and you can see a Q&A button that you can use to submit questions, and I strongly encourage viewers to do that option, use that option to submit questions, and Robin will go through those questions and answer them at the end of our webinar. And we typically have a networking event for 30 minutes from 1 to 1:30, and most of the time we use it to continue with the Q&A session. And so with that said, Robin, please take it over.
Great. Hi, everyone. I'm just going to give me just a sec while I share my screen.
We see that.
How's that, Rajesh?
Very good.
Okay, excellent. Thank you, Rajesh and Olga, for the warm welcome. And I appreciate all the work you do organizing these lunchtime, at least in the East Coast here in New York, webinars. They're great to hear what everyone's doing. And I'm I'm honored to present the work that my team did at IBM Research. So what I'm going to talk about today is using AI to co-develop new product formulations in the future of flavor innovation. And this actually is, relies heavily on a presentation that I gave with my clients. So I hope, as we've done in some of the past webinars, to give you that perspective from the client side as well. So just a little bit of an outline about how the presentation is going to go. I was going to start with talking about the product development challenge. You can see here in this picture a soiree of different kinds of products that we see every day in the grocery store. How do all these products get developed, and what do product developers face when they try to create these new flavors? Then the second part of the talk is going to talk about computational creativity and why we care about it. And then lastly, I'm going to talk about a system that was developed and deployed using computational creativity to address the product development challenge. So let's start off with the client and their problem. So many of you may know McCormick. This is McCormick's logo, and you can see a few of their consumer products. They're over a 130-year-old company, the largest flavor company in the world. They have 35 brands, and in those 35 brands, over 17,000 products are sold in 160 countries around the world. And to create those, they have over 14,000 raw materials sourced from 85 countries. So it's big, large, and complex. Now, you may know McCormick from your local grocery store. You may even enjoy some of these products, like, I come from Maryland and just love Old Bay seasoning. But in addition to their consumer brands, they also have a flavor solution unit. So consumers only about 60% of their business. Flavor solution is about 40%. And they're very different markets. One, they're developing products for you, the end consumers, but in flavor solutions, they have clients, which are other restaurant services or CPG, consumer product good companies that need a flavoring for their products. So they have both consumers and clients. And in their world of client delivery, time is very much of the essence. So this is a little bit about the complexity of the problem that the product developers are working on. The group that creates these new flavors and new products is an outstanding research and development organization. They have over 500 food science and flavor experts around the world in 20 state-of-the-art technical centers in 14 countries. And in fact, Morningstar has said that the McCormick research labs have become the best in the industry in their opinion. And the team at McCormick is very humble, but they just have an outstanding group of people that are facing these challenges of how to create new products, and for us as the consumers. Now, it's been said because McCormick is so big that it's hard in the US and the companies where they are to go 24 hours without ingesting something that has a McCormick product either directly or indirectly in it. So they're always trying to create new products for the changing tastes. And one of the challenges in the flavor product development landscape is the changing consumer. So today's consumers are younger, right? And they're demanding new things. You know, for example, when I was growing up, you know, we had strawberries, you know, in strawberry season, and that was it. Now, you know, for me and my kids, you see strawberries all year long. You know, the globalization of the food system has been extraordinary. And these younger generations not only want to taste all those ethnic flavors, but they also care more about natural and sustainable flavors, which is a challenge for the product developers. So that's the consumer, but in addition, the customers, so that would be the food and beverage services, restaurants, and other CPG customers, you know, they're coming under more stress for cost management and economic value. So it's not just about flavor, it's not about great taste, but it's how to constantly reformulate these products and maintain lower costs and low margins. And then talent. So it takes 5 to 10 years minimum for someone after they graduate from college to become a master product developer. They essentially go through an apprenticeship program. And so they're very rare, specialized and valuable employees. And when they leave a company, they take all that knowledge with them. So there is a war on talent right now. And I talked a little bit about the materials earlier, but there are tens of thousands of raw materials to choose from for a product developer trying to create that next great best product. Let me give you an example. In my kitchen, I have 2 types of garlic. You know, I have the fresh garlic and then I have the powdered garlic. In fact, it's only one type of garlic sold in my grocery store, fresh, and that's what I have. But a product developer at McCormick literally would have 150 different types of garlic. They would have garlic from Asia and garlic from America. And just like Vidalia onions in Georgia have a special flavor based on the soil there, so do the different types of garlic based on where they're grown and even the year. They also have different formats. So a powdered garlic, but they have flaked garlic, garlic granules, and they have granules of different sizes. So they have a huge variety of products. And so there's really a combinatorial explosions of possibilities that they have to deal with. And today in the industry, the only process that's available to them is the stage gate process, which is very iterative and time consuming. And finally, they're constantly being asked to reformulate products for new regulations. So different countries have different regulations. You may know this from eating certain mac and cheeses that, you know, some of the coloring ingredients that are allowed in Europe weren't allowed in, are not allowed in Europe, are allowed in the US. So McCormick product developers have to be extremely agile and keeping track of all those regulations and adhering to them. Not to mention things like formulating for halal restrictions or manufacturability. So overwhelming challenges in the product development landscape facing human product developers right now. McCormick wants to address these because essentially they are a high growth, innovative CPG company. So they have to continually reinvent. And their vision is to elevate the capability of every global team member to the level of the best one. So I mentioned before that they had 500 scientists, right? Well, they have like 200 scientists in Hunt Valley, but only say 12 in New Delhi. And it's difficult to share the expertise of those developers across the globe. And a junior developer may take, for example, 50 to 150 iterations to take a new idea from start all the way to ready for the shelf product formulation. So whereas a senior member may take a third of that time. So what they'd like to do is somehow elevate the capability of everyone in that diverse talent pool. And right now, I mentioned how slow and iterative the stage gate process was. They want to increase that 300%, 3x. Moreover, you may realize that new products on the shelf come and go quickly. 80% don't really last more than a few years, but there are some called icons, which last for a long time, like the Oreo cookie or Philadelphia cream cheese. But how does a product developer find one of those icons that is sticky in the market? So right now it's a needle in the haystack. So McCormick would like to make it easier for their product developers to find those icons, because of course, if it stays longer, then that's less innovation needed. And so they want to make the product development faster, better, and more cost-effective simultaneously. And another trend that that you're probably very well with is the health and wellness trend in food products. So they want to be able to enhance their ability to make healthy products. For example, there's a lot of diseases linked to overconsumption of sodium, a lot of salt in products, but by using certain flavors, you can decrease the salt without decreasing the overall flavor experience. So that, in a nutshell, is a summary of the product development challenges at McCormick and what they'd like to do. So I'd like to switch now to talk about computational creativity. So there's a lot of talk and buzzword about using artificial intelligence for all sorts of business needs. And in fact, IBM research has a long history of creating systems that push the state of the art in artificial intelligence, from the Deep Blue system that beat the world's reigning chess champion, Garry Kasparov, to, creating a computer system like Jeopardy that, like Watson, that played Jeopardy and beat the reigning champions. Google, for example, created an artificial intelligence system that, was excelled at Go. So this is something that's been going on in the computing world, is how to create systems that can think, right? And we typically have been looking at that as completing tasks or games. But the challenge at McCormick is not creating a computer system that can think, right? It's not just that a product developer has to think or just take known knowledge and apply it, like in Jeopardy, where you solve a riddle. It's knowledge that's known. What they need is creative. So it kind of begs the question of what is creativity, and then what is computational creativity. So I'd like you just to take a second and think, what's your definition of creativity? What does it mean to be creative? Are you more creative than than your family members? How are you measuring creativity? This is something that innately we know, but actually is very difficult to pin down, much like the definition of intelligence. I like this definition of creativity. It's by Bowden in '92, and it's essentially the ability to come up with ideas or artifacts that are new, surprising, and valuable. There are lots of different definitions of creativity, but primarily they depend on something being novel and pleasing, and often some other attributes as well. So if we accept this definition of creativity, we can also see that, like beauty, it's in the eye of the beholder. Like what's surprising to you may not be surprising to me. So creativity is very subjective. So for computational creativity, we're looking for a system that mimics human creativity. So Colton and Wiggins had a definition of computational creativity as the philosophy, science, and engineering of computer systems, which by taking on particular responsibilities exhibit behaviors that unbiased observers would deem to be creative. So that's a pretty good definition. Other people have different definitions that don't rely on unbiased observers, but observers that are skilled in the arts. And it's really still an ongoing debate about how to define computational creativity. But there is an association for computational creativity. They've been having computational creativity, if you haven't heard of it, events for the past 20 years. And it's a multidiscipline endeavor that is located at the intersection of the fields of artificial intelligence, cognitive psychology, philosophy, and the arts. Because when I say creativity, most people think about the arts, painting, drawing, music, dance, lots of different arts. So there's even been systems created that do jokes and puns. So I thought I would just give you an example of a computational creativity system. And since we're talking about food, it involves fiber. So what do you call a murderer with fiber? And the answer is, of course, a serial killer. So this joke, this pun, was created by a computer system called JAPE that was created by Ritchie and Binstead in 1994. So, we want to create a system to help McCormick and the product developers. And it's really important that it has that all essential ingredient of creativity to address their needs. So why would you want to think about creativity? Some people consider creativity to be the pinnacle of intelligence, right? It also could be a test bed for your AI techniques, just the challenge of intellectual challenge. But in our case, it's also because of the applications. So the team in, back in 2012 was working to create a computational creativity system, and they decided to work in the area of food. The way this came about, I was told, is because, we have these grand challenges like beating a chess champion or winning at Watson, Watson winning at Jeopardy. Well, they decided, wouldn't it be fun if we could win at Iron Chef, the cooking challenge show? But they quickly realized we didn't have the resources to build robotic systems, so they decided to focus in on the recipes. So they pursued computational creativity as an area of research with the domain of a culinary chef and creating recipes. And they worked with the Institute of Culinary Education. Well, they were very successful, and there was a light bulb moment when the chief science officer, Ahmed Faridi, who you can see here, on Christmas Day, was listening to NPR radio, the host, All Things Considered, Robert Siegel, and there was an interview on his show of two people, that one of the scientists at what came to be known as the Chef Watson Project on computational creativity for recipes with the Culinary Institute. So they were working for the end user of a chef. And he said it was a light bulb moment listening to Lougee talk about computational creativity. It was such a light bulb moment, he had to pull his car over, stop. It was only a 3-minute segment, but he said that segment fundamentally changed his vision for how McCormick was going to work. And so he started thinking about a lot of questions about the possibilities of a computational creativity AI system for McCormick, because he had hired lots of contractors and consultants, and they, had told him that they didn't think it would work. So could we develop an intelligent platform to create product formulas, or one that learns and gets better with experience? Because, eating food is really an experiential thing, and computers can't taste and computers can't smell. So how could we develop a system that wasn't deterministic, but one that learned and could understand what a flavor experience meant for a consumer? And how could they even predict what people would like, because end liking actually drives a lot of their business. And when I use the word taste experience, let me just say a product developer cares not about just a taste at a point in time, but they care about a taste throughout time. So from when you first bite it, that sensation, while you're chewing, masticating, smelling till you swallow. That whole experience over time is what they're designing products for. And they actually formulate them differently so that you will experience different sensations at different points in time throughout that, that period. And another attribute was the human flavorists. Would they accept this? That the flavorists are very highly skilled and very proud, rightfully so, individuals. Would they see this AI as something that was helping them, or would they perceive it a threat? And so he got very excited and reached out and partnered with IBM. And he calls it a match made in heaven. It's really interesting. McCormick is unusual in that they had 40 years of data. So they estimate that they'll have 1 billion data points by the end of 2021. Lots of chemistry, food science data, and over 400,000 flavor and food formulations. That's unusual. A lot of people don't store that data over such a long period of time in that industry. And that was what made this collaboration successful. So based on the conversation, what he heard on the NPR talk, he was very excited, but there's one problem. Is that Chef Watson was targeted for chefs. You put in an ingredient, a cuisine, and it helps you come up with new recipes. Product developers are night and day different from chefs in the view of McCormick. The underlying approach that was used in Chef Watson had some theoretical attributes. When humans typically do creative acts, there are many different types of creativity. In recipes, we're looking at combinatorial creativity, where you're taking lots of different ingredients, mixing them in different proportions to come up with a new recipe. That you try a lot of things and figure out which ones are good. It's sort of like a try and evaluate approach. So when you want to do the trying, that part's easy, right? It's kind of easy to just mix things together and come up with something that's new. The difficulty is coming up with something that's new and good, or new and useful. So you need to have some sort of measure of good, right? Some quantitative measure of what's good. So in the Chef Watson project, they use the idea of Bayesian surprise. So in Bayesian surprise, we're essentially looking at the difference between a prior distribution and a posterior distribution, and looking at that difference to see if what happened between the prior and the posterior was large, then we say that's very surprising. But if they're essentially the same, we say it's not surprising. So this work did not match McCormick's view of how to proceed. Moreover, the Chef Watson used the idea of the flavor hypothesis pairing, in which case foods that share the same compounds, chemical compounds, go well together and should taste together. So for example, you may go to a restaurant and see chocolate leek cake. They share similar ingredients. So by adding a small amount of leeks to chocolate cake, it really makes the flavor bigger. And so that doesn't necessarily hold throughout the world. McCormick is a global company. So although we've been inspired, Hamed had been very inspired by the work with Chef Watson, when it came down to it, we had to start off with a different approach. So the way we decided to approach the work had to do with thinking about the flavor space. So this was very natural to product developers to think about exploring the flavor space. And so we needed a way to digitalize the flavor space so we could explore it. And of course, being mathematicians and computer scientists, a very natural way to do it is with the notion of distance. So how do we take flavor and digitalize it so that we can explore the space and define mathematically the space in a way that a computer can reason about it? So we want to be able to generate suggestions new formula suggestions for product developers that taste great. And we're giving them not just the ingredients to use, but the ratio of ingredients to use. So in this schematic here, the product developer may be looking in some area and they have a notion in their head that there's a fruity space, there's a savory space, there's a sweet heat, maybe a spicy heat, there's a creamy space and floral space. The challenge in doing this is that even this characterization isn't standardized. Like there's no IEEE description, IEEE, standard for what these different areas are, let alone how to characterize them. So let me talk to you about how the McCormick product developers interact with the system, and then I'll drill down into how the actual heart of the algorithms work. So in the case of McCormick product developers, it's really directed creativity. We tackle the problem at the point where a new brief has been given to a product developer. A brief is a description of what they should develop. Like I want a smoky hot sauce that doesn't have a taste of ash. It's very descriptive and they have to interpret that. And the way it works is they come up with a seed formulation. So a formulation is a list of ingredients and their relative proportions. And that is the input to the system. And then they can either revise that formulation or just simply go with that initial guess formulation and create a sample. So by creating a sample, they physically compound, they physically make what that whatever it is that they're making. So in this case, this spice, the sauce, and then they apply that to the protein, let's say, if that's what they're cooking, and then they evaluate it. So this is the hedonistic evaluation. So human beings tasting it. The gold standard for taste is human, for flavor experiences is a human. And so that's what's done. And so they take those evaluations, and based on that feedback, they go back to the lab and reformulate the revision. And this right here would be one iteration. And so what they want to do is try to reduce that 50 to 150 iterations down to make it more quickly, better, and faster. But once they get something that passed a certain hedonistic score, typically a 6.5 to 7, then they have something that's ready to be submitted either to the product development team at McCormick or to their client if it's their flavor solutions business. So this is the part here where the AI system engages with the product developer. So let's drill into that a little bit. So how the IBM AI for product composition system works, so it works like an apprentice, and it's trying to learn the patterns and the best practices from the product developers through the historical data. So we have a body of historical data. Here it's the materials, the raw ingredients and the attributes about them. And the attributes depend on what kind of materials we have. It's the formulas in the repository. And here it's not just the winning formulas, but it's the formulas that didn't work, because we want to be able to learn about what didn't work as well as what did work. And then evidence of success. So evidence of success could be a formula getting picked to be compounded, right, to be evaluated. It could be something that was sent to a client. It could be something that was bought by a client. It could be the amount of time that it's been being sold, but we have some success evidence that we want to learn from. So this body of information, and we have 5 machine learning models. They're substitutes, complements, application, distance, and success. So first off, we're trying to learn patterns. So substitutes are a kind of pattern. So for example, in your kitchen, you may substitute flour for cornstarch. These are functional substitutes. They do the same thing, but they're a little different. Or lemon for lime. Slightly different taste, but they both serve as an acid in the recipe. We use machine learning models for complements to find complements. Complements are things that go together. So basil and oregano often go together in Mediterranean dishes. And then application. This wasn't originally in the system, but the system was given a challenge of finding a Cajun rice mix spice. and the system did its magic. And when it came back, it came out with a suggestion that had no rice in it at all. It was a very beautiful Cajun seasoned salt recipe. So quickly learned that the system needed to have some knowledge about what kind of application the user was working from. Because remember, this is directed creativity. The user has a goal. They're starting with that brief in mind. And then finally, I'd mentioned distance. So we're formulating the problem in terms of exploring things in flavor space. So there's a notion of distance. And this is important because you want to be able to sometimes be a little creative, and sometimes you want to be a lot creative. So you want to make sure we're looking in space near where that initial seed was, right? Because we have a target. And so we use the idea of distance. So we define distance between two formulas, and formulas are tuples with the ingredient list and the relative proportions of those ingredients as the earth mover's distance. That's one of the metrics we use, which is a kind of optimal transport problem, as you know, derived from the Wasserstein metric. So we have a notion of distance that we've derived. And then finally, success. That's what helps us choose between good formulas and bad formulas. And using those 5 machine learning models and other data, the AI system generates technically sound formulas that are hopefully good. So one thing that happens is that the AI algorithm creates a lot of suggestions, but we don't want to show those all to the users. We want to focus them in. We have a focus area that's based on the target and the distance. And then we try to generate, we have to figure out which ones to show the users based on their goodness. And so we try to cover that space well. So for example, if this is the focus area here, there may be some existing formulas that already exist. So depending on the application that we're working on, the users may not want to see those. They may just be too similar to the existing product space, and they might be much more interested in what exists in the white space. So we also have a covering problem in here. And I mentioned the idea of different levels of creativity. For a product developer, often they're trying to not make something that's wildly creative, but their job is to make something taste better. So for example, how do you take an Oreo cookie and make it taste better, right? How do you make a cheese snack taste better? So there's creativity involved into it, but it's more that they're optimizing the flavors because the different mixes of ingredients can have the same flavor taste. And other times they do actually want to be able to explore and find completely unusual ingredients. So the system is trying to support not just one usage from the product developers, but it's been designed to support their whole life cycle of tasks that they do throughout their, throughout their work. And so our notion of creativity is actually a scale. We can look at farther, more increasing distance. So we built this system, and it actually was deployed at McCormick in production. Many companies, as you know, are experimenting with AI, but they tend to be proof of concepts. What's really exciting about this system was that it got deployed into production, and the product developers got to work with it. So all the data was put into the system. We had our 5 models that we learned from. This design patterns of both the substitutes and complements, which are building blocks of creating new suggested formulas. And that we then processed to show the best ones, where best means also we're covering the space. They're targeted to the area they're looking at, and they have a high likelihood of success to show to the product developers. So this is a little different view of the same system. And we're very excited that it actually seems to be of value to McCormick and work. You know, one of the reasons, or one of the things that's very different about this project than any other project I've ever worked on, is that the data that McCormick has of the formulas of the customers that it works with, that it's trying to improve, it's trade secret data. This literally is the secret sauce. So we worked to a large extent in encoded data. So in other, OR type projects, knowing the customer's data better than the customer itself was one of the ways we're able to add value. But in this case, we had to develop technologies and insights with the data being screened, and then have, later on find out how well it actually worked. So there's a different level of complexity. But McCormick found that by using the system, they were actually able to reduce their product development time in some instances by 70%. And it became the basis for 3 flavors when they launched the one platform. So one product, if you're not familiar with it, is the seasoning that goes on protein and vegetables. So you can cook it in one sheet pan or one skillet. And 3 of those products, McCormick came out publicly and said were enabled by the AI system. And so they are scaling this technology. And in 2021, they hope to have it deployed across all their global labs and expect to reach that target of a 300% increase in their innovations. I'm very fortunate that McCormick and IBM went public with this work. In February 2019, they published a joint press release to announce this work, and the interest was really phenomenal. Had more than 100 placements, including the front page of a special section on the Wall Street Journal's Future of Food. There's also a paper that was written for a food science journal, if anybody's interested, and YouTube videos. So I've talked a little bit about the challenge of the product developers and a little bit about computational creativity and the system that we created. And to McCormick, it's not just about, or the chief science officer at McCormick, it's not just about using computational creativity for them, but they really see this as revolutionizing the product development industry, how product developers work, because they're being able to equip their product developers with improved starting points, help them to more quickly develop their products, because the system combines silos of knowledge from around the world. It's elevating everyone's ability through that team of 500 global scientists. So a global view is really essential to having one global R&D rather than having a series of separate silos. And that the kinds of data that the product developers are able to have access to inherently through the AI allows them to integrate sensory data, from the start in the process. So from McCormick, it's my hats off. I think it's a very visionary project, and I've been very grateful to be able to be a part of it. So let me just tell you a little bit about what McCormick is telling the world about it, is that they're saying this computational creativity system is giving them creative advantage. And not just for the food and the flavor, but also to be able to think about having to reformulate products for cost, for health and wellness, for sustainability, for carbon footprint. They really think that this is going to be a new way of doing things. And that it's had an impact in how agile they've been for their customers. I mentioned the flavor solutions portion of McCormick's business. So they're given a bid. They bid on, say somebody wants a new strawberry flavoring, all the flavor houses in the world would then compete. If they can be the first person to come up with a good suggestion, they can get feedback, and that's a competitive advantage to them. So actually the ability to do things quickly is huge. I mentioned the talent war that was going on. McCormick has had people, very highly sought after product developers, come to them and to be able to hire them because they're working with AI. And of course, people who are leaders in their field often want to work with the latest and greatest technology. So it's actually has become a magnet for better talent for them. And they're using it to advance their flavor portfolio. I don't know how many products in total now have been developed with the AI tools, but the product developers don't call this AI. they call it their innovation partner, right? So they don't see it as something that replaces them, but they really see it as like the digital assistant to them, and it's helping them tremendously. Looking ahead, McCormick has always, had this problem that there's only so much shelf space for their products. So looking to e-commerce and the ability to want to mass customize their products, they just could never take that on its scale because they couldn't develop enough products quickly enough. But a tool like the computational creativity tool allows them to do just that. And they're very excited about the opportunities for personalized flavor, which is related to personalized nutrition. So from the customer's perspective, they're very excited about the future of flavor using AI. And so I've talked about flavor, and I'd love to talk more about flavor in the Q&A, but I just want to mention that flavor is only one application of product development. A lot of the things that we've been talking about have analogs to fragrances or cosmetics or laundry detergents or lubricants or concretes, right? Many consumer products have to be redesigned every year. New products or the same problems with having to reformulate for globalization reasons or different regulations, or a raw material is no longer available. So, it's going away. So you have to get something different. And so the system that's created at IBM Research is actually more generally applicable. And actually in 2019, it was used to develop the first AI fragrances that were sold by O Boticário in Brazil, that were launched in time for Brazilian Valentine's Day. IBM had a partnership with Symrise, and so they were the suppliers to O Boticário, and it worked very much in the same way. Though I will say, from my perspective, I think that fragrances, are mostly olfaction to much greater extent than flavor is. Flavor has a lot to do with other senses as well. So I just like to say a big shout out to the phenomenal team at IBM Research here, who I had the pleasure of working with. I'm no longer with IBM Research, but it was a joy and my honor to work with them and do this. And thank you for the time today to let me tell you about the work.
Great. Thank you very much, Robin. Very unique application. I hadn't really thought about it in that sense. And Beth, if you can please unmute the audience, so if people have any questions, they can ask those questions. And before we start with any questions, I just want to make sure that, hey, first of all, thank you again, Robin, for coming and making this presentation. And for those in the audience, we hope if you like these kind of presentations, and again, we have 3 series within the practice section, that you will consider becoming a member of the practice session. So if you have any questions, please speak up. I guess you are all unmuted now. You can unmute yourself. And while we are waiting, let me start off with a question or two. So Robin, you talked about, right in the beginning, you said flavorists are in strong demand and so on. And I guess my question is, how do you evaluate or judge a flavorist? It seems like such a subjective term. Is it just because you're able to be more creative? Is being more creative necessarily good in this business, or are you, just by being more creative, going back to flavors which have previously been discarded?
Yeah, I think there's a lot of questions in that very good question you just asked, Rajesh. Yeah, and to me also, it's like it's so subjective. I mean, flavor, humans are typically said they have 5 senses, right? We have sight. Look at what AI has done with sights. How image processing can be done faster by a machine than a human, right? And that's because we've been able to digitalize images, right? We have pixelation and the RGB values. So we've digitalized it and been able to work on the problem of giving computer sight, right? Listening, text, your voice to text is another problem that we've been able to tackle because we've been able to digitalize it. So what about olfaction and taste? Touch I'll leave out because there are a lot of robotics in that, but touch, taste, and olfaction, gustatory and olfaction are the least studied senses. And the reason is because it's just so complex. In the area of flavor, as you probably know, you may have been taught that, your tongue has these little sections of sweet, salt, savory, umami, and it's not correct. It's much more complex. Your perception of taste involves your eyes. For example, they did a study where they took 2 glasses of wine and asked people to rate them. Little did they know, one was really red wine and the other was white wine with red food coloring in it. And they evaluated the white wine as if it was a red wine, proving that sight influence it. When you eat, that crunch, right? That affects your perception of taste. And that is tactile, right? It's also audio if you hear a crunch, right? So really, I think flavor is about one of the most complicated domains to really work in because it involves all of that. So how do we do this? I think when most people hear about flavor work, you think about yourself as being a chef. You think about you in your kitchen and, what are you going to make tonight and how's it going to taste, or following a recipe. That's similar to a product developer because yes, they do have a formula and ingredients, but it's also really different. And I'll give you an example. Let's say you want to create a potato chip, right? A flavoring potato chips. I showed you that line of potato chips in that chart. Have you heard they can't have just one? You've heard that like commercial, right? All right, so there's a whole science of how do you create that response? That response to have the next potato chip happens because of what your taste is at the very end of that flavor experience journey. So for example, you may not have one garlic in it, you may have multiple garlics, you may have a very fine powder so that when you crunch the potato chip, the fine powder coats your taste receptors on your tongue. But see, that washes away very quick. So you may have to have a larger size granule so that at the end of that flavor experience, you'll have it. A product developer, when they're formulating a product and trying to decide what's good, they're thinking about that. So it's not just the problem of a chef. A chef has maybe hundreds of ingredients. Product developers, thousands, completely different. Chef can think about like a very expensive, rare balsamic vinegar. Product developer, no way. They have to think about being able to get those products and what's available. So it's very different. And often a product developer is trying to make a flavor better, like strawberry. If I say the word strawberry, you know what it tastes like, right? Well, there's green strawberry, there's juicy strawberry, there's ripe strawberry. There's like a whole lexicon of strawberry flavors that they're trying to develop and improve on. So it's very different, and they evaluate them on a hedonic scale, which they're experiencing as humans the flavors that have a target, and then they're codifying in numbers, how they rate that. And that's the input they give back. So they have an agreed upon way or scale, though it is subjective, to say what's better. So I've rambled a little bit, Rajesh. I hope that a little bit answers your question.
Rajesh is on mute.
Yes, yeah, thank you. Yes, I was on mute. So absolutely, you did answer the question. And I know there were a lot of related sort of a small questions, and I think you tried to address most of them. Before we go to Ranganath, there are a couple of questions on the Q&A panel. Robin, if you can open that panel.
Sure. So I see one question from Irv. So in case people can't see it or are listening to the tape, Irv Lustig asks, if you're applying this to other product, you still have to have a good data set like McCormick to know what are good products versus not, right? Yeah, I mean, in these computational creativity systems, these AI systems, you got to have a good data set. And I think that is gating the adoption by other companies to applying these kind of techniques is because who else would have incurred the expense of keeping around product development data for 40 years, right? Because we're learning from what works and didn't. So I think that's been a huge competitive advantage for McCormick, but you need data. And, you know, we were talking about, you know, the hundreds of thousands of product formulations, you know, and the 15,000 some odd raw materials. I think the other thing about this data is you all as mathematicians know is that, you know, there's data and there's data, right? How many ingredients actually show up in any formula? You know, it's more than 20, right? So how many times is your the raw material that you may be the best one for a new application, are you going to have data about that? So it's not just having data, but it's that kind of quality data, and how might you try to capture that as a consumer product company. I think that the fact that this work has been successful for McCormick, they have seen at least 70% reduction in time. They've proven, all those consultants who said there's no way that a system could be done wrong. So I think that's really sparking a lot of interest by other companies to start on that data of creating data sets for this. And many people are also experimenting in their own right. I mean, the whole area of the digitalization of flavor is really, really fascinating right now. So great question, Irv. The second question on the open Q&A is from Vahide Abdi, excuse me if I mispronounced that. He said, I'm curious if the process of cooking can be captured in these applications. In many dishes, the process of cooking with the exact same ingredients makes a very large difference in the final flavor. So yes, you're absolutely right. So I think what you're pointing out, Buddy, is that actually in many products, there's process steps. Like, do you bake or do you boil? You know, do you distill? Do you, you know, are you frying? So the Chef Watson system actually worked more in that domain. Our current system, the one that I was talking about, was only combinatorial creativity in the sense they were looking at combinations of ingredients and the relative proportion. And let me just say that was very challenging enough for us. It's still very much an ongoing research effort. We've by no means, you know, cracked the nut on everything that McCormick wants. But I think there are other people very much looking at the kind of applications that you're talking about. We also include process steps.
Ranganath, you have a question?
Yeah, Robin, great talk. I enjoyed it a lot. Just a question about this process of interaction between AI part and the human beings. Like, how did that happen? The AI could come up with the formulation, and then somebody would make that formula, and the human beings would test it and evaluate and give some score and feedback to the AI. Is that how it worked, or was it something different?
Yeah, great question. I just want to say that that one of the things that we were very fortunate to have in the champions at McCormick for this work in Hamed Faridi was that he is a scientist, you know, by training. And now the chief scientist. So he's not just a business person, but he's a scientist. So some of the things that we struggle with when we deploy applications to end users, he was on top of. For example, including the end users at the very beginning of the process and understanding change management. So they actually hired a dedicated organizational psychologist to work with the product developers and the whole McCormick, you know, to help them adopt to this tool, because we're not automating an existing process, right? There's a lot of great work that does just that. But what McCormick's doing is reinventing how their product developers work, so changing it. So there's many different, I talked about one use of the system. You know, there's many different uses and many different visualizations and tools. But in what I talked about, the product developer brings a seed, so the starting point, to the system. And then they can play They can search inside the system. They can play, they can generate suggestions. So you start with your starting point, which is a recipe with ingredients and amounts, and you can say, generate suggestions based on this. And so the system pops up like a dozen high qualified suggestions based on what it knows. All the system knows is that seed. Actually, the human knows a whole lot more because they've read the brief, right? They know what direction they want to go in. And so there's still that gap there. So the system can suggest things to them. They can use it or not. They can take that suggestion and take half of it, or they can reject it. So there's a loop there of how they interact. And then you exit that loop when you decide that, okay, I want to taste this. So then it gets compounded, it gets applied in whatever way, like if it's a potato chip coating, and then it gets tasted, and then it goes back. So it gets evaluation. So that information about what gets chosen, how it got evaluated, that goes back into the system so that we can continue to learn from it. So did that answer your question, Ranganath?
Yeah, no, it does. I was thinking in this particular application, would something similar to genetic algorithm would have done similar things, because also you're going to get some new suggestions every. Okay. Did the advantage come from the fact that computer was suggesting many alternatives that the human beings would not think for their various biases?
Yes, and I should have made that point. And I have, like, one of our early successes was there was a product developer who was doing pizza seasonings. So I'm a human, I'm thinking pizza, I'm thinking Italy, Mediterranean, right? So I'm thinking, Italian spices. Well, the system came back and recommended cumin, right? And so the human had this bias of what does it mean to be Mediterranean pizza? The computer system didn't have the same bias. And so it noticed that cumin generated a warmth and suggested that back to the user. And the user thought, wow, that's kind of interesting. And there's a lot of different examples like that. And I think one of the interesting things is that the human product developer has to decide if it makes sense or not. So I've also, in this case, the product developer thought that was really cool, tried it out, and they liked it. But there is a gate there where you have to win over the product developer's trust to try something that's outside their comfort zone. I mean, because they're working under a pressure, a time pressure in some instances, they've come up with their own kind of go-to formulations. Like there's hundreds of different cheeses. So they'll come up with their own go-to on how to have a cheese flavor. So what the system will do is it doesn't know that. It knows what the rest of the product developers have tried over the years for cheese, and it might suggest that. So you have to hopefully have a product developer who will adopt or at least be open to trying what the system says. Otherwise, it would never work.
Thanks, Robin.
Oh, and I should mention, Ranganath, that the chief science officer said he personally almost contacted every single human product developer as a part of this project to keep them in the loop and make sure there was no unforeseen problems. I think that's pretty amazing commitment.
Yeah. Thanks.
Any other questions? I don't think so. There are no open questions anymore. So, Robin, I think we'll stop here today then. Again, thank you again for this wonderful talk. And again, for the audience, please consider joining the practice group as well as the Women in OR group, as the case might be. A video of this talk would be posted on the webinar homepage. You can go to the homepage and there is a list of past webinars. And again, if you have any questions or comments, please send them out to me in terms of any new speakers or some speakers or a particular business on which you would like to see a talk. Just send any suggestions to me. Thank you again, Robin, for a wonderful presentation. And thank you, Olga, for being a co-host on this one.
Thank you very much, Rajesh. Thank you, Robin. It was a wonderful talk.
Thank you, Olga.
Okay, thank you. And thank you, Beth. Right.